So we'll start out our topic today focusing on reactive programming principles, and you'll see why this is an important topic. This topic is something that we'll cover here, starting with completable futures, and then we'll move on and also cover it when we talk about reactive streams. And I'll talk briefly in just a little bit about the relationship between completable futures and Java streams and reactive streams and the reactive programming paradigm. What we're going to do now is we're going to talk about some of the key principles that underlie the reactive programming paradigm. So probably a good idea to start by defining what reactive programming is. So reactive programming is essentially an asynchronous programming paradigm that involves processing data streams and propagating changes to from various publishers to various subscribers or producers and consumers, depending on how you like to talk about it. If you take a look at the link at the bottom of the slide, you'll learn more about reactive programming as a paradigm. So reactive programming is particularly useful to support certain types of scenarios. What would those be, you might ask? Well, one of them involves processing events that come in from users. So for example, if you're programming on a mobile device or you're programming a user interface on a desktop or a laptop or so on, then you have various things that users provide as input. So mouse movements, mouse clicks, touch events. Then there's also other things that kind of fall into the same sort of bag of events like GPS location signals, which correspond to where the user happens to be moving. And so as you'll see, the reactive programming approach is used very commonly in the context of graphical user interfaces. Now, we're not really going to do a whole lot of it here in this course because this course isn't really a course on GUIs, although you could use this capability, and in fact, it is used quite commonly in platforms like Android. Likewise, another common place for using reactive programming and processing events are responding to and processing latency-bound I/O events, things where you need to be able to handle input from networks or maybe file systems, but particularly networks. So handling network input and output asynchronously is also a very common place where reactive programming is used. For example, as shown here, we have a model where events are coming in from, say, a Twitter stream, and we want to be able to do various types of analysis to those events, do things like filter them based on topic, be able to do sentiment analysis to see what's trending, grouping things according to interests that may be differentiated by different users who subscribe to different events, and so on and so forth. So once again, you have this concept of a flow or a stream of events, and we want to do some kind of processing on that flow or stream. Now, in some ways, that sounds a bit like a Java stream, and we'll see that there are some dimensions of reactive programming that have some things in common with Java streams, although the whole concept of asynchrony is really at the heart of this in a way that you don't see quite as much with Java parallel streams. Although, as you'll see later when we talk about completable futures, you can combine completable futures with Java sequential streams in quite nice arrangements. There are 4 key principles in the reactive programming model, and those principles are basically responsive, resilient, elastic, and message-driven. So let's talk about each one of them in turn. We'll start by talking about responsive. And what this means is that the systems that are designed using reactive programming are intended to provide rapid and consistent response times. And what that means more specifically is that you want to be able to have reliable upper bounds on the time taken to deliver events, to be able to give consistent quality of service, quality of experience, and try to prevent delays. Think about it this way. If you're using reactive programming for things like mouse events or clicks, you want to be able to make sure that you don't fall behind the user and have a noticeable lag in the system. Likewise, if you're trying to process a stream of events that are coming in from Twitter or stock market, stock quotes, and so on, you want to make sure that you don't fall behind and start losing events. Another important principle of reactive programming is resilient. And what that means is that the system should remain responsive and remain operational, even in the face of partial failure. In particular, failure of some operations, some processing should not cause the entire system or the entire program to come crashing down. And that's also very important if you want to build systems that are intended to be highly reliable, the so-called 5 nines reliability, where you want to have very little downtime over long periods of time. Yet another important principle that kind of underlies the reactive programming paradigm is the concept of elasticity. And what that means is the system should remain responsive even when the workload varies. And another way of looking at that is commonly referred to as auto-scaling. So you want to be able to add new cores, add new computers in some cases, and so on, and be able to do this in a way where as the load goes up, the resource utilization goes up. And conversely, of course, as load goes down, you want the number of resources used in the system to also go down. You don't want to have to pay for what you don't need, to quote the Liberty Mutual tagline for insurance. And then the fourth and final principle is something that's called message-driven. And this means you want to have asynchronous message passing between components that are decoupled, so they're loosely coupled. They're relatively isolated, again, to help out with things like resilience. And you want things ideally to be location transparent. You want to be able to run your components in different threads, different computers, and so on, without having to do a lot of extra surgery to your code in order to change it to work in those different configurations and different deployments. And this principle is a little bit different from the other three. The other three are really more about concepts and about capabilities. This is a bit more of an implementation detail, although you'll see that it also is applied in interesting ways as we look further at different implementations of the reactive programming paradigm. So that's a quick overview of some of the key principles for reactive programming. And then what we're going to do next, of course, is start to see how these things map onto different dimensions in Java and other technologies too, of course, but we're going to be primarily focusing on Java.